Some of the operations like union and intersection, already you know about them. So the other operations I define. For example, complement of a set. Complement of a set is defined like this: collection of strings x such a way that x belongs to sigma star. That means x is one of the possible string in sigma star. Second one, and x does not belongs to a. For example, if a equal to 0, 0, 1, 1, 0, then a complement is, first of all let us list out sigma star: epsilon, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, so on, right? The negation A is other than 0, 0, 1, 1, 0, epsilon, 1, 0, 0, and of course 1, 1, so on. So this is a way negation A can be completed, or complement of A. Now one more operation which we use very frequently, that is concatenation between two sets. So here A is a collection of strings, B is a collection of strings, then A dot B is again a collection of strings. So that is in the form of xy, where x belongs to A, y belongs to B. That means for any x belongs to A, y belongs to B, simply write x dot y or xy, then that will be a string of A dot B. For example, A equal to 0, 0, 1, B is collection of strings 1, 0, 0, then A dot B is, according to the definition, you write xy whenever x belongs to A, y belongs to B. See here, x belongs to A, y belongs to B. Then xy should belongs to AB. So that's why it is 0, 1, 0. Similarly, if you think this as x, this as y, then you get again xy 0, 0 will be in the set. Similarly, if this is also x, right, and this is x and this is y, then it would be 0, 1, 1, 0, then 0, 1, 0. So now we got an idea of writing systematically. So write all the strings with this and this combination, and the first string and second string, then second string followed by first string, second string followed by second string. So then you get A dot B. We will take one more example. A equal to epsilon comma 0. Let us take B equal to epsilon comma 0 comma 1. Then what would be A dot B? So according to the definition, so see, this is x and this can be y, this can be y, this can be y. That's why epsilon, 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 epsilon dot 0, 0, epsilon dot 1, 1. So then this can be x, this can be y. So that's why x dot y is 0 dot epsilon, 0, and 0 dot 0, 0, 0, and 0 dot 1, 0, 1. These are all possible strings in A dot B. So this is a way we can define concatenation operation among the sets. Now we will see power operation, a to the power of n. So a is a set. A to the power of n is defined like this: a to the power of 0 is defined as epsilon, and any a to the power of n plus 1 if you want, then you simply take a dot a to the power of n. Let us see with example how it works. So here a equal to, let's say, 0, 0, 1, then a to the power of 2, let us calculate, equal to a dot a to the power of 1. So what is a to the power of 1? A to the power of 1 is a dot a to the power of 0. So here a to the power of 0 is defined as epsilon, right? Let me write an epsilon string. Now one observation, so you know one thing, you know concatenation operation, how to do it? Take each and every string of A and concatenate with all the strings of this other set, but other set contains only epsilon. Then you take each and every string, and if you concatenate, then you get your strings back. That means, example, you have a string x1 in A, then x1 dot epsilon x1. Similarly, if you have x2, then you get x2 back. So that means you get only those elements which are in A. So that's why a dot epsilon is A, correct? So what I want to say is a power 1 is actually A. So a square is a dot a power 1, which is a dot A. Similarly, a cube you realize as a dot a dot A. Fine. Let me do a square here. A square is 0, 0, 1 dot 0, 0, 1. If I do it, you get 0 dot 0, 0, 0, 0 versus 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1. Now a cube is, according to the definition, a dot a square. So a is 0 comma 0 1, a square is 0 0 0 0 1 0 1 0 0 1 0 1, right? Then how many strings you get because of this 0? If it is concatenated with these 4, then you may get 4 strings. Then 0 1 is concatenated with these 4 strings, again you may get 4. Why I am saying may? Because there might be some duplicates. Example, here if you have 0, here if you have 0, then you get 0 0. What if you have like epsilon here and here 0 0, then epsilon dot 0 0 is 0 0. That means when you do concatenation between two sets, then you might get duplicates. That you should understand. So but in this case you get all 8 distinct strings. Let us see what are they. 0 dot 0 0 0 0 0, second one 0 dot 0 0 1 0 0 0 1, 0 dot 0 1 0 0 0 1 0 0 0 1 0 1, then 0 1 0 0 0 1 0 0 1 0 1 0 1 0 0 1 0 1 0 1. So this is about a cube. So let me define a star. So a star is defined as a to the power of 0 union a to the power of 1 union a to the power of 2, so on. If you want to write a strict mathematical notation, then it is a to the power of I. See, a to the power of I is union, right, where I greater than or equal to 0. Now see, a to the power of 0 union a to the power of 1 union, so on. So this is another notation. Now we'll see one example. Sir, what is empty power star? So according to the definition, it will be empty power 0 union empty power 1 union empty power 2, so on, right? So here any set power 0 is epsilon. So then epsilon union empty set power 1. So empty set power 1 is, any set power 1 is the set itself. So that's why empty set union empty square is defined as empty set dot empty set. Then already I told you, take each and every string of the first set and take each and every string of second set and concatenate them. First left elements followed by right elements. So then there is no element here, then that's why you don't get anything back. That's why it is empty. Union empty cube. So here easily we can understand that empty cube is empty dot empty square according to the definition. But empty square is, just now we realize that it's empty, but again empty dot empty is empty. In that way, so everything will become empty. Then you get only one element, that is epsilon. So empty set is actually a set with 0 elements. So empty star is a set with 1 element. That's why please note the difference. There are 3 things which often confuses you. One is epsilon, empty, and this is a set with empty element. Set with epsilon. The difference between these 3, actually this is not a set, this is a string. This is a set which doesn't contain any string. This is a set which contains one element. Of course it's a string, and that is null string. That means the length of that string is 0. So that's why these 3 are completely different entities. Fine. So this is not a set. These 2 are sets, but this contains only 0 elements, and this contains 1 element. Sometimes, that means most of the times, other than empty star and a set with epsilon star, this is homework for you, do it. Apart from these 2, you take any set A, then you get infinite elements in A star. So let us do that. So A star is here is same story, a power 0 union a to the power of 1 union a square, so on. So a to the power of 0, if I write, already we know that it is epsilon union a to the power of 1 is set itself. Let's calculate a square. So many times we have already calculated, right, this 0 1 dot 0 1. Then you get 0 0 0 1 1 0 1 1. So one small observation is a square contains all possible strings of length 2, and especially which are made of 0 1, correct? Yes. So then my claim is, if you do a cube, then you get all possible 3 length strings. Why? I will tell you. Because A square contains all possible 2 length strings, you remember it, 1 0 1 1. Then if you concatenate with 0 1, any 3 length string is made of, you can divide it into 2 parts. So this is 2 length, this is 1 length. So any 3 length string which is made of 0 comma 1 definitely ends with either 0 or either with 1. Okay, these are the only two things. Now we have to ensure that A cube contains all possible strings which are ending with 0, all possible strings which are ending with 1. Then it is nothing but proving that we have all possible strings of length 3, correct? Now, so because here A square already contains all possible 2 length strings, then when you concatenate, then here you get all possible 2 length strings. So that means all possible 2 length strings are concatenated with 0, all possible strings of length 2 are concatenated with 1, then you get all possible length of 3 strings, right? So that's why I can say that A cube is nothing but all possible 3 length strings of 0s and 1s. Similarly, A to the power of 4, A to the power of 5 you can argue. So now if I write A star, here it is nothing but first all possible 0 length strings epsilon, because we have to write A power 0, union A power 1, all possible 1 length strings 0 1, A square 0 0 0 1 1 0 1 1. When you do the union with A cube, the new elements will be that's 0 0 0 0 1 so on, because it's infinite sets, I'm not writing all of them. Now one more way we can define A star, so that is A star is a concatenation of x1, x2, x3 so on xn, where each xi belongs to your A. So whenever you write any string in the form of x1, x2, x3 so on xn, where each that xi should come from your A, then we say that if you collect all of them, then you form A star. So that means, for example, if A equal to 0, 0, 1 and 1, 0, then I'm just defining A star as, with respect to this definition, x1, x2, x3 so on xn. Fine, each xi should belong to A, that's it. Yeah, so let me take 0 1, it belongs to A, 1 0 it belongs to A. So 0 1 dot 1 0, so if I take, then is it not in this form? See, this is x1, this is x2. So up to some n. So here, sir, what is n? N can be anything greater than or equal to 0, you remember. So here now x1, x2, that means my n is greater than n equal to 2, right? So second condition, each xi belongs to A. Yes, 0 1 belongs to A, 1 0 belongs to A. Then 0 1 1 0 should belongs to your A star. That means 0 1 1 0 will be included in that way. So whenever this condition is satisfied, all such strings if you collect, then it forms A star, right? Now we'll see associative property, commutative property, distributive property, De Morgan's law, and how many of them are applicable for this union, intersection and concatenation. Of course, you know about union and intersection, that's why I'll go a little bit quick over them, but when it comes to concatenation, then I will discuss. So associative, union and intersection are associative. That means A union B union C equal to A union B union C. Similarly, A intersection B intersection C equal to A intersection B intersection C. Now concatenation is a new operator for us, that is also associative. That means A dot B dot C equal to A dot B dot C. Remember it. Second thing, commutative property. We know already that union is commutative and intersection is commutative, but concatenation is not commutative, right? A dot B not equal to B dot A. It's easy to see. Let me take a simple example. If A is a single symbol 0 and B is 1, then 0 dot 1 gives you 0 1 string, whereas B dot A gives 1 0, right? Now, so before going to distributive law and De Morgan's law, I would like to introduce two special sets. Of course, you know them. One is empty set and second one, this is a set with epsilon. So here, this set with epsilon element works as identity element with respect to concatenation operator. Example, if you take A dot epsilon, already we have seen it, and epsilon dot A, then you get your set back. It is identity property, right? Yes. So this empty set is called annihilator. That means if you take A dot this empty set, that is equal to empty set dot A is always equal to empty set. You take any set, that will be destroyed, you always get empty set back. In multiplication, 0, right? 2.0 equal to 0.2 equal to 0. Same way. Now we will see distributive law. So of course you know about union and intersection. So union is distributive over intersection, correct? Intersection is distributive over union. So A union B intersection C equal to A union B intersection A union C. Similarly, A intersection B union C is A intersection B union A intersection C. Fine. Now what about concatenation, sir? Concatenation is also distributive over union. So A dot B union C equal to A dot B union A dot C. Now we will prove it. If X belongs to A dot B union C, then we have to prove that X belongs to A dot B union A dot C. So that is one direction, because we have to prove the equivalence. For that, if X belongs to A dot B union C, then X belongs to A dot B union A dot C, we have to prove. Second thing, if X belongs to A dot B union A dot C, then we have to prove that X belongs to other set A dot B union C. Let me do that. So first we assume that X belongs to A dot B union C. See, we know that if X belongs to A dot B union C, there should be two patterns x1, x2, such a way that X equal to x1 dot x2, where x1 belongs to A, x2 belongs to B union C, correct? That is the definition of concatenation. So X belongs to A dot B, then there should be two strings x1, x2, such a way that x1 belongs to A, x2 belongs to B. That's why in the place of B we have B union C here. Now let me take it. If x1 belongs to A and x2 belongs to B union C, then I can say that x2 belongs to B or x2 belongs to C. That's the logic, right? Now if x1 belongs to A and x2 belongs to B or x2 belongs to C, then according to the logic, x1 belongs to A comma x2 belongs to B, that is one case, or x1 belongs to A, x2 belongs to C, that is the other case. Now, so x1 belongs to A, x2 belongs to B, then x1 dot x2 will belong, x1 dot x2 belongs to A dot B, correct? Now x1 belongs to A, x2 belongs to C, then x1 dot x2 belongs to A dot C. That's the definition of A dot B and A dot C. If x1 dot x2 belongs to A dot B, where x1 dot x2 is actually x, right? Then x belongs to A dot B. So in the middle we have R. So R, x belongs to A dot C. So finally we proved that x belongs to A dot B or x belongs to A dot C. So that's one direction. Yeah, we proved this direction. Now we'll see this one. Let us take x belongs to A dot B union C. X belongs to A dot B union A dot C. For that, x belongs to A dot B or x belongs to A dot C. If x belongs to A dot B, then maybe x is in the form of x1, x2, where x1 belongs to A and x1 belongs to B. So then only x, which is x1 dot x2, belongs to A dot B. Or if x belongs to A dot C, definitely there should be two strings x1, x2, such a way that x1 belongs to A and x1 belongs to x2 belongs to C. Now you see, if x1 belongs to A, x1 belongs to B, or x1 belongs to A, x2 belongs to C, I can say that x1 belongs to A is compulsory, and this one x2, the x2 belongs to B or C, correct? Yeah. So that means x1 belongs to A. If x2 belongs to B or C, then x2 belongs to B union C. So I can say that x1 belongs to A. X1 belongs to A, x2 belongs to B union C. Since x equal to x1 dot x2, then x is nothing but x1 dot x2. But we know that x1 is coming from A, x2 is coming from B dot B union C. Then x1 dot x2 belongs to A dot B union C. Correct? That's the definition. So that means x belongs to A dot B union C. So this is the way you have to prove equations. Either you remember it, but also learn how to prove this kind of statements, because in the interviews if they ask prove that A dot A intersection B union C equal to A intersection B union A intersection C, how you do that if you don't know, then you definitely will confuse and definitely you will be rejected. That's why fundamentals should be clear on any subject. This distributive rule not only applicable for union of two sets, it can be applicable for union over multiple sets. That means, example, if you have multiple sets, let me use an index set like 1, 2, 4, 7, 9. You understand why I am using this. Then B1, B2, B4, B7, B9 are the sets. See, I am using 1, 2, 4, 7, 9 to index them. See, so sir, why are you using this? Still we did not understand. Now I use Bi where I belongs to capital I. If I write like this, that means for every I belongs to your capital I, there is a set called Bi. In that way, with one single variable, we can define multiple sets, right? Now the question is A dot B1 union, B2 union, B4 union, B7 union, B9 is equal to A dot B1 union, A dot B2 union, A dot B4 union, A dot B7 union, A dot B9. Fine. So that means, let me write a good notation, formal notation. So A dot B1 union B2, because already we know that these all sets can be represented with single variable Bi, but we have union between them, you see. So that's why this entire B1 to B9 union can be written as union of I belongs to capital I Bi. So that's an advantage. Now A dot this entire union of all that B sets equal to, according to the formula, it would be A dot B1 union A dot B2. Sir, can we simplify this? Yes. So here you see the structure is same, A dot B, 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 right? That means A dot sum B. So let us use Bi. So here this I varies from, that's why. So I varies from 1 to 9, correct. So that one more thing. So all that A dot Bi's are union, right? That's why we use union here, where your I varies from 1 to 9. That means I belongs to capital I. So this is usage of this notation. Because of this notation, what happened? A big formula is shortened, right? That's an advantage. So definitely we have to learn these notations. Already I told you the reason. In the exam, suddenly if this kind of notations comes, then you will get confused. You don't have any idea how to understand them. And you know the game of GATE, right? Within 3 minutes you have to answer the question. For that, you should be able to understand these notations quickly. Quickly means seriously quickly. Fine. Now one more important property, which is dot versus intersection. So dot is not distributive over intersection. That means A dot B intersection C may not be equal to A dot B intersection A dot C. That's a question. So why, we will see. We see some formulas which are helpful for us in understanding this further lectures. One is A star dot A star. So we'll try to understand it. So you know the definition of A star, that is going to help you in understanding A star dot A star. A star is some sequence of strings x1, x2, x3, so on xn, where each xi belongs to A, right? Remember it. So that means it's a sequence of strings which are coming from A and which are concatenated. Similarly, you take another A star, then that is also. So let me take this time other variable too, because I am going to concatenate to not have ambiguity. So let me take another variable. Nothing is wrong, right? y1, y2, y3, so on. Let me take ym, where each yi belongs to A. That is again a definition of A star. If you do A star dot A star, what is going to happen? According to the I am doing A star dot A star, then you take a string pattern, you take another string pattern from both sets. You know the definition of A dot B. So A dot B contains all the strings of A concatenated with all the strings of B. So this represents all the format of all the strings of A star. So let me write it. So it means x1, x2, x3, so on, xn. Such format strings are concatenated with y1, y2, y3, so on, ym. Please observe that this x1, x2, x3, xn represents all possible strings. Okay, so here also this represents all possible strings of the first A star. y1, y2, y3, so on, ym represents all possible string formats of or strings of A star. Now where I can say that each xi belongs to A, yi belongs to A. You can see here I am writing it again, x1, x2, so on, xn, y1, y2, so on, ym, where each xi belongs to A and each yi belongs to A. See here, finally you are writing some sequence of strings which are taken from A, again some sequence of strings which are taken from A, and you are writing concatenation. That's the definition of A star, right? So that's why I can say that instead of writing different variables, I can say simply x1, x2, so on, xn. Then y1 can be written as yn, so y1 can be written as another variable of x like xn plus 1. y2 can be assumed as xn plus 2, so on. The ym can be assumed as xn plus m, where so each xi now belongs to A. Now you see, just understand it. Don't worry about how many how many strings we have. Just understand the notation. The notation's meaning is you take some strings x1 to xn plus m, where each such string is concatenated and each are coming from, everything is coming from A. So that is exactly the definition of A star. You see, some strings are coming from A and which are concatenated. Here also some strings, correct? So that's why I can say that this is exactly A star. Now we'll see one more thing, A star whole star equal to A star. Why? So why A star whole star is A star? To understand, I use this definition. So any set star is defined as, example, you know that B star is nothing but B power 0 union B power 1 union B square union B cube, so on, right? But in the place of B, now I assume A star, then it would be A star whole star equal to A star power 0 union A star power 1 union A star power 2, so on. But we know that any A star is just a set, right? A set power 0 is always a set with empty string. Union A star power 1 is A star. Union A star whole square is nothing but A star dot A star. We know the definition of power, right? So A star dot A star, just now we have seen, is A star. Now in the same way we can understand that A star dot A star dot A star, which is A star whole cube, because A star dot A star is A star, let me write it, let me replace it, dot A star. So A star dot A star again A star. In that way every other element will become A star. So then if you do the union, then you end up with only two things. You see, epsilon union all the A stars. A star union A star is A star, right? So no new string is there other than like the strings of A star. So that's why I can say that epsilon union A star. But A star, if you expand, you know that A star's definition is it. So first question, let me ask a question. A star contains an element called epsilon. Yes or no? Yes. So when you do union of this set with only epsilon, then already A star has an epsilon element, then you don't get any new element. That's why you get only those elements of A star. So that's why I can say that epsilon union A star is A star. Fine. So finally we realize that A star whole star is A star. Now finally we learned some of the important and useful operations related to sets and strings.